Okay. Hi everyone. The project I've been working on for the last year has been what I call a hydroponic sensor system. Essentially, it just controls online. Oh.
Take your headphones off. That's so rude. Eric has the floor. Give him your attention. That's unbelievable. Okay, Eric, I apologize for that. Let's go.
Okay, so I've been working on what I call a hydroponic sensor system for Mrs. Scanlon's, the eco-action team, kind of a research project. Essentially what it does is it can read in sensor values using, you can make your own custom sensors and stuff, and it can control I guess any 120 volt AC source. In this case, it'll be a pump. So some of the challenges I've faced in this project, first of all, have been like security, not in the normal sense, but in the fact that this is a research project, so nothing can go wrong with the data in any sense. Or actually, what I meant to say is it's more of an industrial application. And when you do that, you want to make sure that nothing can go wrong. So, for instance, inside here, I have this. It's called uninterruptible power supply. It's a battery, and it allows you to.
You might want to come closer and check the stuff out, guys.
If you'd like to. Essentially, it's a battery, and it allows you to. It's like a backup battery, for example. You can charge up, and it'll just keep the pump running in case the power goes out. I'm using the Arduino with this Ethernet shield to essentially give our data, and that's kind of how I'm making sure that it's nice and secure. And if the power goes out, then it'll stay running and stuff like that. For the sensors, obviously I'm using Ethernet for the communication with the internet. But for the sensors, I'm using a protocol called I2C. Essentially, so here's like a sensor. I'm just using this RJ45 jack to kind of plug in. But essentially, so there's your power, and there's these two data lines. So essentially what it does is it allows you to name this channel. So for example, this one is on channel 99. And this Arduino, no matter where this is plugged in, it can be plugged into any of these ports. And it would allow you to go in and retrieve the data. So it's very flexible. I have 3 sensors right here, and it only uses 2 pins on the board. So it's very, very effective, and it allows you to do a whole range of sensors. So for example, if I wanted to, I could plug in this one. It's on channel 99, and it'll read it perfectly fine. Or this one, which is on, I think it's on a different channel. Or built in, another component of it, I want it to be very educational. So I've built in a smaller Arduino, which allows you to, people in the future, to program that chip with custom sensors. Maybe the researchers want some sort of like water absorption sensor or CO2 sensor, something like that. So I've built into there a chip that they can program however they like, and that's going to communicate with my main board. So I guess there's a few challenges that I've had to overcome, and it's really helped me learn I guess how to make a project in an industrial setting where, as you can see, all this the fittings are watertight. I've had to like pot this together because I couldn't really find any good sensors, and yeah. And additionally, I don't have it on this one yet, but I'm making 2 right now. So on this one, another thing that I guess in an industrial setting, you want the end user to be able to very easily adjust settings without you having to come in. I'm leaving for college next year, so I obviously need someone else. So I've just kind of made this little paper that allows kids to go in and watch these videos. So example for different people, like if you need to maintain it because there's some problem, or if you're interested in the research side and you really don't want to mess around with electronics, or if you're a programmer and you want to program that chip, or if you're just interested in the fittings or how to waterproof stuff like that. I have all these different ideas, all these different I guess videos for different people. And also I have a website with all the files on it, and I have an overall manual. So I guess that's a few things to consider when you're trying to make something for somebody that's not necessarily as technically or knows all the programming know-how that you might know. So, yep, that's my project.
Cool. Yay. All right. Okay, questions for Erik. This is a cool project.
How long have you worked on it? Just this year?
So it's been kind of a culmination. It's been kind of a culmination of multiple years. So when I first did the project, it was very, very specialized. So essentially, the main project was using this pH sensor, and it didn't use I2C. It used like very, very specialized code. All the program could do is just read from this specific sensor, and I had a little web server that essentially just dumped all the data on. It wasn't pretty. You couldn't access it from like the whole internet. You had to be on the particular LAN that you were on. So that obviously had its problems, but that's kind of what I had at the time. And then over time, later in the year, Adafruit's company that does electronics, they came out with a little service that kind of allowed you to do kind of the same thing, but upload it to the whole internet. And then finally, I've been working with another project that's called My Devices that essentially allows you to kind of like plug and play with these systems, I guess. Make it very easy to get data onto the internet and kind of manipulate it and get data back onto the Arduino. So that's kind of been a progression over the last couple of years.
Any other questions? Victor.
So this might come just from me because I'm in class with you, but a problem that I saw was it's really hard to make new boxes. You said you wanted it in an industrial setting. Have you ever thought of scaling this up into like a real business, or like ever reintroducing this to like a marketplace? I don't know.
Yeah, so matter of fact, some faculty have kind of asked about it and said they have their own little gardens, and like a few people actually have kind of talked about how they're going to be like away from their other house and stuff, and they kind of like it to be, they're like plans to be walled and stuff like that. So the way I've set it up is, like I said, the I2C. So essentially that allows you to have like nearly like 1,023 sensors or 1,024 sensors if you want. So you could have a ridiculous amount of sensors on here. If you wanted to expand, if you wanted to have like a mini one with just 2 sensors, you want to have a huge one with like 10 sensors, you could do that. And same thing with the water. So if you have different parts of your house, you might want to water. So yeah, so I've thought about making an industrial thing for like a commercial project. So I've thought about that, but obviously college and stuff would get in the way. That's kind of been a cool dream of mine to be able to make it industrial. That's why I've kind of set it up kind of like a company. Like I called it Sensorponic, just playing around. But it would be cool if I could make it a real thing.
Cool.
I like how it's like user friendly, meaning that not many, even if you're not technical, you can still like figure out. And basically for the competition too, we try to simplify everything down to what others can also understand.
Mm-hmm.
Right. The whole idea is that it kind of brings people together. So it's bringing like the industrial design, engineering people. It brings programming people. It brings just people who are interested in the research all together.
I like the QR codes.
Thank you.
Yeah, that's so smart.
Yeah.
Type this 150 character link into your browser.
Okay, cool. Thank you.